Pressure, how's the network? How are you? Guys, if the network does funny things, then I actually literally was doing a grade 10 lesson and the network was fighting hard, very hard, very, very hard. So the network is great now. Oh my soul. I'm guessing like my poor grade 10s are cursed, that's for sure, because the network was fighting bad. Yo. Yeah, so let's just hope it maintains this good nature of itself, because it was bad with the grade 11s. It was good at the beginning, but then it ended badly, ended very badly. So yeah, I'll just have to the grade 10s, I'm just going to have to do, because those grade 10s asked me to do a video rather and post it on my YouTube channel, so I'll do that. I'll post the video. I'll post a video of what I was gonna do, maybe just like small segment videos, and just post them and upload them all on the YouTube link. So I'm very sorry about that to the grade 10s, but now I have the grade 11s and hopefully the network holds. Guys, today we're gonna do nature of roots of nature, the nature of roots. So hopefully you guys have done that at your respective schools. I'm hoping this is not going to be for the first time that you are being exposed to this topic, and that it will just sort of like add more muscle to what you already know, and then you will flow in it very nicely as you ought to, because there's nothing in this thing, to be honest. Nature of roots is just it's just another nice topic, by the way, if you want. Okay, yeah, so let's start immediately, so that then by the time the network starts doing funny things, I'm through. So here's the thing: for any equation in this form, so in the form ax squared plus bx plus c, I'm sure you are so sick and tired of seeing this equation by now. Like, I am so sure you guys are just like, you've had it. If you had your way, you would probably like put a revolver on its head and just shoot it, but you have no choice. You just have no choice. So ax squared plus bx, so for any equation in the form ax squared plus bx plus c, you guys know that this formula, which one? This formula, x is equal to, and maybe you guys are gonna tell me what this formula is. This formula, x is equal to minus b plus minus the square root of b squared minus 4ac over 2a is used. What formula is this? Yes, the quadratic formula. Yeah, you guys know the formula, eh? You've had fun with it, right? And I'm sure now you guys are so lazy to factorize quadratic equations that you simply just use this formula at any given moment, okay? Hopefully your laziness does not overwhelm or overcome you. But anyways, I know you love it. You should definitely love it. So this formula, x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. This is what we refer to as the quadratic formula, as you have rightfully said. Now from it, for nature of roots, we are interested in this part of the formula, all right? We referred to that part of the formula, we referred to it, all right? This thing, we refer to it as the discriminant. We call it the discriminant. This expression, b squared minus 4ac, we refer to it as the discriminant, and this symbol here, this rectangle symbol, we refer to it as delta. Okay, we refer to it as delta. The symbol itself is called delta. All right. The expression b squared minus 4ac is the discriminant. All right. And it's basically this expression that is under the square root. So this expression b squared minus 4ac is situated under a what? A square root. Guys, I hope you understand that. It's very important to understand that, because this thing of nature of roots, you know, the discriminant, if you want, okanye delta. Okay, I want to say in very short wording that the discriminant, or what you guys refer to as mod delta, okay, is it actually determines, okanye, I know some people say determines, it determines the nature of the roots, okay, without solving the equation, without solving the equation. The discriminant, or delta, helps us to determine, okay, the nature of roots without solving the equation, right? So this is very important. This formula, the quadratic formula, we can extract, or we can pull out b squared minus 4ac underneath the square root. That part, that magical part, helps us to be able to do what? To determine the nature of roots without solving the equation. Okay, so my grade 11s, please take note of that. Okay, so in other words, when we say the nature of the roots, what are we talking about? Okay, we are basically saying, you will remember that whenever we solved an equation, we would get a quadratic equation, we would get two solutions. Those solutions, you will remember, we referred to those solutions as what? We referred to them as the roots. Okay, we referred to them as the roots. Okay, and we can talk about the nature of the roots. In other words, we can talk about what are those roots. Okay, and we can talk about those roots under three things, and that is: one, we can state whether, and I'm going to say, we can state whether the roots are real or non-real. Okay, in other words, are those roots real numbers or are they non-real? Okay, that's one aspect of the nature of the roots that we can talk about. Two, we can talk about whether those roots are unequal or equal. Okay, and of course, we can only talk about those roots being unequal or equal if only those roots are real. Okay, very important. If the roots are real, we can talk about them either being equal or unequal. And furthermore, we can talk about the roots being either rational or irrational. We can discuss the nature of roots under these three things, under these three subheadings, if you want. Okay, right? And like I said, unequal or equal, and then rational or irrational. We can only discuss roots being unequal, equal, rational or irrational only if the roots from the beginning are actually real. But interestingly enough, for non-real roots, the minute we say the roots are non-real, then basically they are just non-real, and we cannot speak about them being unequal or equal, rational or irrational. So they can only be non-real only if they are non-real. But if they are real, we can speak furthermore and state, are they unequal or equal, or are they rational or irrational? Okay, so this is very important, that from real we branch out to these two subheadings additionally. But for non-real, we cannot branch out to these two subheadings. We can only talk about them being non-real, full stop. Okay, remember, non-real means imaginary. Okay, imaginary numbers. And obviously, we cannot say imaginary numbers are equal or unequal, or they are rational or irrational if they are non-real. I hope that makes sense. Okay. So I'm just gonna say again, roots. What are roots? Roots are the values, or they are the solutions of x whenever we are solving an equation. When solving an equation. So let me go back up again. Well, how did I start off this thing? I said for any equation in the form ax squared plus bx plus c is equal to 0. All right. We know that this formula, this one, x is equal to minus b plus minus the square root of b squared minus 4ac over 2a, which is this formula, we refer to it as the quadratic formula. From this quadratic formula, we have what we refer to as the expression under the square root, which is referred to as b squared minus 4ac. We call that the discriminant, or delta. Thank you so much for the rose. We refer to this as the discriminant, or delta. Okay, delta is just the Greek, guys. Okay, you know, the symbols in the Greek language, they use this symbolism, which means delta. All right. So more appropriately in English, we refer to this as this b squared minus 4ac. We refer to it as the discriminant. So the discriminant, or delta, what does it do? It helps us to determine the nature of roots without solving the equation. Okay, maybe some of you are like, okay, without solving the equation, what's the significance? Guys, if we want to determine the nature of roots without solving the equation, we use the discriminant. Okay, but if we want to determine the nature of roots while solving the equation, we can solve the equation and get the roots, and we can talk about them. Okay, now there we go again, my network. Guys, please let me know about network stability, because this network is really sabotaging things today. How's the network, guys? You just let me know in the comment section, how's the network, okay? How we're experiencing the network. Okay, good, thank you. Okay, the network is great. Okay, I saw that I'm seeing the yellow thing here, and instability. Usually it's okay, it's very stable. Okay, now then I said, when we discuss the nature of roots, or we determine that nature of roots, when we comment about the nature of roots, we comment about the nature of roots under 3 subheadings. Now the 3 subheadings will apply only when the roots are real. When the roots are real, you can furthermore state whether they are unequal or equal, and you can furthermore state whether they are rational or irrational. Very important. But the minute you find out that the roots are non-real, then you can only state that they are non-real, full stop. You cannot say anymore. You cannot say non-real and then talk about the additional 2 subheadings. You cannot comment further. All right, okay, I hope that makes sense. Then roots. What are roots? Roots are simply the values or the solutions of x. When solving an equation that is quadratic, we call those solutions that we get at the end, we call them the roots of the equation. Okay, and that was established earlier on when we did quadratic equation and we solved quadratic equations. Okay, so let's look at a few questions here, and I just want you to then appreciate the following. We have a question here, and it says, determine or determine the nature of roots without solving the equation. All right, and the equation is x squared plus 5x plus 4 equal to 0. And they are asking us to do what? Determine the nature of roots without solving the equation. So very importantly then, what we do, all right, and I'm just going to suggest a quick method, especially since they're saying without solving the equation. All right, someone did ask me earlier on, do I have a YouTube channel? Yes, I do. Go to my bio. There's a link there. It's the YouTube link. It's called Maths is a Game. That's basically the YouTube channel. And the live sessions that I hold here, I upload them after I'm done in that YouTube channel so that you can watch those videos in your own time. You can even watch the videos that I've done earlier on with the sessions done, you know, for other topics like inequalities and others. They are there. You can check it out. I have a playlist for the grade 11s. You can watch the videos that we've done previously. So the method that we have here is, first and foremost, we need to make sure that the equation is in standard form. Okay? Very important. Equation must be in standard form. By that I mean it must be in the form ax squared plus bx plus c is equal to 0, ensuring that our a value, meaning the coefficient of x squared, is what? Is positive. Please, guys, all right? Just make sure that that is the case to begin with. 2, identify, after putting the equation in standard form, a, b, and c. Remember, the value of a is simply the coefficient of x squared, b is the coefficient of x, and then c is the constant term. 3, substitute into delta is equal to b squared minus 4ac. So you're going to first write down this equation. So I'm going to say write down and then substitute into delta is equal to b squared minus 4ac. So this triangle, guys, delta is equal to b squared minus 4ac. Then you follow that up with substitution. Then 4, you comment, or then 4, you then obviously get the value of delta, and then you comment. Okay, and I'm going to show you guys step by step what I mean by all of this, okay? And maybe just also some specific things that maybe will assist you in your commentary, okay? So let's do this for this question. As you can see, x squared plus 5x plus 4 is equal to 0. This is already in what? In standard form. Second part, identify a, b, and c. So a is equal to, I think someone already had typed there, a is equal to 1, very true. B is equal to, the coefficient of x is positive 5, very true. C is equal to, as you have said, positive 4, very good. Then, let us not then forget to write down the formula for the equation of the discriminant, or the expression of the discriminant. Delta is equal to b squared minus 4ac. Next step, we substitute. And when we substitute, please people, let us substitute using brackets. Please, brackets, I beg you, brackets, oh please, brackets, oh please, please, brackets, please guys, brackets indeed. Then 5 squared, we know it's 25. Minus 4 times 1 times 4, we know is negative 16. Okay, then we know that delta is equal to 9. Okay, yes, brackets. Okay, delta is equal to 9. All right, now I want us to note then the following. We've thus found that delta is equal to 9. So there are 2 things that we now know, and that is 1, delta is greater than 0. Very important that you follow this up. After writing delta is equal to 9, this value is a value that's greater than 0. And also delta is a perfect square. How important, guys, that we write this as we determine the value of delta. Delta is equal to 9. The value 9 is greater than 0, meaning delta is greater than 0. Guys, when you write this, it's very important. Delta is also a what? A perfect square. Now you can comment on the nature of the roots. Then you say roots are. Remember the three things that I mentioned we comment under. We can either comment real or non-real. Now the thing is, guys, the minute we say delta is greater than 0, that suggests that the roots are real. So the real part comes from the fact that we've stated that delta is greater than 0. That means the roots are real. 2, you have rational or irrational. Okay, now the minute you say delta is a perfect square, that suggests that the roots are rational. Okay, if delta was not a perfect square, then we would say the roots are irrational. And guys, stop for a moment. Why are we saying that? Okay, remember, where was delta situated? B squared minus 4ac is an expression situated under a square root. And remember that if this value under the square root is not a perfect square, then it would suggest that the values of x that we get are actually irrational. Okay, if this is not a perfect square, the value that's underneath the square root, then it would mean that the value of x, the roots that we would get, would be irrational. On the other hand, if the value under the square root, which is representing the value of this expression, is a perfect square, then that would suggest that the roots are rational. Okay. This is very important. So if delta is a perfect square, it means that the roots are rational. Then last but not least, the roots are equal or unequal? They are unequal. Why do we say unequal? The thing is, the roots are only equal if delta is equal to 0. But in this case, delta is equal to 9. So if delta is equal to any other positive number, then we know that the roots forever remain as being unequal. So I just want you to understand that because you said delta is greater than 0, there are two things that you can immediately state about the roots. Firstly, the roots are real. That comes from delta greater than 0. Delta is positive. 2, the roots are also unequal because of delta is greater than 0. Then delta is a perfect square. That is why we say that the roots are rational. I want you to understand where the power to say real comes from. Okay, the power to say real comes from the fact that delta is greater than 0. And then the power to say unequal comes from the fact that delta is greater than 0. And the power to say delta is a perfect square, or the power to say the roots are rational, comes from the fact that delta is a perfect square. And guys, that is the question beautifully answered step by step. And honestly speaking, I would say that if you've done all of this, make sure that the equation, the quadratic equation, is in standard form. You identify A, B, and C. You write down the expression of delta. You substitute the values. You get the value of delta. You state what the condition of delta is based on the value, the fact that it's greater than 0 because of that. Delta is a perfect square because 9 is a perfect square number. Then conclude about the roots. Roots are real, 1, rational, 2, unequal, 3, 100% correct. Okay, I hope we're together here. Okay, let's look at another question. Under the same sort of question, determine the nature of the roots. And this time round, x squared plus x plus 1 is equal to 0. So let's look at this one. X squared plus x plus 1 is equal to 0. Determine the roots. Woman of faith, you are asking, why are they unequal? The thing is, okay, the reason why the roots are unequal is because delta is equal to 9. This 9 is a number that is greater than 0. If delta is greater than 0, then it means that the roots are unequal. Okay? It means that the roots are unequal. In other words, you would get two values of x that are not the same if you were to actually solve this equation. That's what it means. When delta is greater than 0, the roots are unequal. The only time when the roots will be equal is if we get delta being equal to 0. Then the roots are equal. Okay, so as long as delta is greater than 0, it will forever speak to the roots being unequal. All right, but if the delta is equal to 0, then we would say that the roots are actually equal. Okay, so I hope that makes sense now. But if it doesn't further, woman of faith, you know most, you can always contact me on the site, definitely. Determine the nature of roots. X squared plus x plus 1 is equal to 0. All right, so same thing. First things first, ensure the equation is in standard form, where a is a positive, and yes, it is. 2, identify a, b, c. So in this case, a is 1, b is 1, c is definitely 1. Unhlanhla is like got this very well understood. I can see Unhlanhla is on the money there, Mr. Nhlanhla Hlobe. Okay, precious way ahead of the team. Delta A is equal to 1, B is equal to 1, C is equal to 1. Then next thing, we write down the discriminant. Then 2, we substitute the value in brackets. Okay, please guys, there would be a big difference for some things if you don't put the brackets. 1 minus 4. Delta is equal to 1 minus 4 is negative 3. Now from this, delta is less than 0. Why are we saying delta is less than 0? 4 is a constant. Yeah, this is negative 4. A is 1. C is 1. Negative 4 times 1 times 1 gives you negative 4. Delta is equal to negative 3. Delta is less than 0. Okay, delta is less than 0. So if delta is less than 0, okay, and obviously delta here is not a perfect square, obviously, okay, at all. It's not a perfect square at all because obviously this is a value that is less than 0. So that would mean roots, not delta, roots. Okay, remember that the discriminant will inform us about the roots of the equation. Okay, so we are saying delta is less than 0, but the roots are the ones that are non-real. Please guys, okay? And remember, what did I say earlier on? I said if the roots are non-real, that's it, full stop. We cannot say anything more than that. Okay, remember, in other words, when you say the roots are non-real, it means there are no roots. Okay, in other words, we are saying there are no roots. Now, how can you say something more about something that does not exist? Okay, does that make sense? So here, the roots are non-real, meaning there are no roots. The equation has no solutions. Okay. Okay, Presh, you've answered woman of faith very well. Okay, yes, indeed, woman of faith, that's how it would be. Okay, if we would get to a place where we get an answer that says delta is equal to 29, I mean, let's just Let's just say we had worked out, and then we got to a certain situation where delta is equal to 29. Okay, then that means delta is greater than 0, and it also means delta is not a perfect square. So then that tells us a few things about the roots. Remember, guys, we're not talking about the nature of delta. We're talking about the nature of the roots. Delta helps us to be able to discuss the nature of roots. Okay, so this PS stands for perfect square, guys. Okay, maybe let me write it down. Yeah, I tend to abbreviate perfect square to PS, right? Okay. Yes, KG, that's the case. So when delta is negative, the roots are always non-real. True, I love that, guys. Not delta is non-real, but the roots are non-real. Delta helps us to be able to discuss the nature of the roots. Okay, so don't ever make a mistake and say delta is non-real. No, the roots are non-real. Why? Because delta is less than 0. Okay, so that's very important. The roots are non-real because delta is less than 0. Okay. Yeah, so hopefully that makes sense, because it has to make sense, guys, in that sense. Makes sense, guys, in that sense. Intercepts in A, there are no roots, there are no x-intercepts, which means it's just like that, no roots. Okay, no roots at all. Okay, and then just to kind of validate what a woman of faith was asking about earlier on, if we say delta is equal to 29, okay, two things about that. Okay, two things about it. It means delta is greater than 0. Okay, and it also means delta is not a perfect square. So we then conclude roots are what? They are 1. Since they are greater than 0, we know they are real. 2, rational or irrational. Since delta is not a perfect square, it means that the roots are irrational, not rational. They are irrational. And then last but not least, the roots equal or unequal. Obviously, since this is not great, this is greater than 0, all right, it's not equal to 0, it means that the roots are unequal. Very important. Very, very important. So the roots are real, irrational, unequal. Okay, so thanks for asking that question, faith woman of faith. Okay, it's funny, people are saying let me do exam questions and all of those things, but guys, do you understand that conceptually you need to first understand the concept behind the nature of roots? Okay, you go to exam questions when the concept is solid. Okay, yeah, I'm glad that some of you have done this long time ago. You see, more pressure. See, you know, they know this is just nothing. It's nothing to them. They feel it. Yeah, but it's cool, which is good. I'm happy that that's the case, guys. It's always good when people know these things and they know them well. Yeah. All right, so oh, I was asking about, oh, I see, KB, oh, I see. Hey, my daughter, people, KB can always go to the YouTube channel, man, and he can, if he wants to do exponents, I've done exponents. You can go to the playlist for the grade 11s and you can check out exponents. And yeah, they are there. Okay, here's another question. Minus 3x squared plus x minus 4 is equal to 0. Okay, so all in all, this question, minus 3x squared plus x minus 4 is equal to 0. You also, guys, this here we need to make sure first, and yes, go to my bio, trench. On my bio, sir, on my bio, there's a YouTube link. You can actually go and click on that. It will send you straight to the YouTube channel. Not the WhatsApp channel, the YouTube channel, buddy. That's the one. Because also again, we need to make sure this is in standard form where the coefficient of x squared is positive first and foremost. So yes, Presh, we divide by negative, and when that happens, everything changes. Divide by negative, divide negative, you get 3x squared. Divide by negative, you get negative x. Divide by negative, you get positive 4 equal to 0. So this then is your standard form. Okay. Yes, KB, that's the one. I think we've got like 700 and something now subscribers there. So yeah, it should give you an idea, Why do we divide by negative? Because we want the coefficient of x squared as positive, Trench. The coefficient of x squared must be a positive so that we can then proceed with the next step, okay? Analyze the discriminant, okay? And that's just the standard rule that I sort of like say all learners need to do. And then you apply it to everything. For inequalities, you always ensure that the coefficient of x squared is positive all the time, guys. Why? Because you want to avoid having a negative sign for the term that has the highest degree exponent, which is x squared. Want to avoid that, okay? Then now we can identify A, B, C. A is 3, B negative 1, and C is beautiful 4. Then sweet stuff. We just take Khoi, write down the discriminant, substitute using our beautiful brackets as I normally say we should. And guys, do you see where the danger would be if we do not put brackets? Because remember, if you didn't put brackets and you said minus 1 squared, remember minus 1 squared with the bracket and minus 1 squared without the bracket is different answers, okay? And it would lead to a different discriminant value, and basically you would then conclude with a value that is incorrect. So we must always put brackets for the values that we substitute into the discriminant expression. Very important. Then we can go ahead, we get 1, and that's 12 times 4, which is 48. So that's negative 48. So once again, what do we get? A negative value. Do you see that, guys? A negative value. This negative value, what does it mean? Delta is less than 0, very importantly. Okay, all right. But I mean, we wouldn't even bother ourselves and talk about it being a perfect square or not, because this is a negative value, all right? And remember, if it's a negative value, we know that therefore the roots are what? Let's see in the comment section, what will people say? The roots are? Woman of Faith definitely needs to comment on this one. I want to see. The roots are? Drum roll. Why is other people's thing is being limited? A woman of faith is crying. Don't cry. Okay, don't cry. Roots are very true. They are non-real. Remember, whenever delta is less than 0, it means one thing and one thing only, and that is the roots are non-real. In other words, there are no roots. So if there are no roots, how can you say when there are no roots and say, no, the roots are also equal and the roots are also irrational? You can't say anything more than just the roots are non-real. You can't comment about something negative 47. So underneath that square root, remember, this would be the value that would be under the square root. And you guys know that a negative number under a square root would basically mean that that's basically non-real, okay? So basically the roots are themselves non-real. Why? Because there's a negative value under the square root. The discriminant is a negative value. Delta is less than 0. So therefore we say that the roots are non-real, full stop. Okay? Okay, we don't even comment about delta is not a perfect square in the situation. In actual fact, guys, even here, we wouldn't even go that mile of commenting about it being not a perfect square or being a perfect square. Why? Because this is a negative value under the square root. So we don't bother ourselves about that being a perfect square or not. I hope that makes sense. We only talk about delta being less than 0, delta being less than 0. But it's when delta is greater than 0 that you can start to comment about delta being a perfect square or not. Okay? Yeah, only when it's positive. So sorry, I did obviously extend my comment there, but I shouldn't have. That was a grave error from my side. Okay, even though it is kind of true, but I mean, yeah, let's try and limit, you know, what we say when the value of delta is a negative value. We can only just say delta is less than 0 and then roots are non-real, full stop, because we don't want to say anything more than that. Hope that makes sense, guys, and I hope it really brings solitude to the soul. I want to do this last one. Okay, this one is also saying discuss the nature of roots without solving the equation. If they say without solving the equation, guys, it simply means that use delta. If they say without solving the equation, they are saying use delta. But let's say, for instance, they would say to you, determine the nature of roots by solving the equation. Then you'd have to actually solve the actual equation, solve for x, get the roots, then comment on those roots as you see them. Okay? Yes, women of faith, discuss and determine is the same thing. It's just different phraseology to ask the same question. So if they basically phrase it differently, okay, just remember in your head it means the same thing. Okay? Sometimes in maths, they just try to be tricky by changing the wording, and then you guys get thrown off completely, you know. It's like they throw a spanner in the works. So same thing here. Standard form, we're already in standard form. Identify A, B, and C. A is 1, B is 2, C is -3. All right. Then we go and write down delta is equal to B squared minus 4AC. We then substitute B 2 squared minus 4 into A times -3. Then we go ahead and we say 4. What's -4 plus 1 minus 3? We get positive 12. We get 16. So delta is equal to 16. Then obviously we say delta is greater than 0. Delta is a perfect square, because 16 is a perfect square number. I'm sure you guys can see that. Then you can conclude from this. Delta is greater than 0. Delta is a perfect square, which means from this we can say roots are what? They are real, obviously. Delta is a perfect square means the roots are rational or irrational. They are rational. And then last but not least, they are unequal. The roots. Okay? Yeah. So this is one type of question you can get. Okay? One type of question one can get is where you are being asked, what is the nature of roots? Discuss the nature of roots. Okay? That's an important question to be asked when they are asking you discuss or determine the nature of the roots. Okay? Now, I want to look by solving for x. Okay, so I'm just gonna do it, women of faith, just so that you can know, like, it's nothing in particular really, actually. So let's say they had said, okay, and this question is very rare. It's not like they ask you this. So if they were to say determine with solving equation the nature of roots. Remember, all what this means is that they mean do not use the discriminant. In other words, when they say determine with solving the equation the nature of roots, they are saying do not use the discriminant. So in other words, they are purely saying that just take, okay, let's say they asked us to solve or to determine the nature of roots for this equation. X squared plus 2x minus 3 is equal to 0. So you know, how do we solve this equation? We can solve it by factorizing. This is already in standard form. So we can factorize it. The factors of negative, factors of 3. Okay, 3 and 1, obviously, because that's a prime number. But since it's a negative sign, it means we're going to have different signs inside the bracket, one positive, one negative, and the factor that is the highest will have the positive sign. So the factors of 3 are 3 and 1. The highest factor will have the positive sign. The highest factor will have the positive sign. Remember, when the constant is negative, it means that we are going to have different signs. But the highest factor will adopt the sign of the middle term. It's always the case, guys. If this was negative, still for a constant, it means we're going to have different signs, but the highest factor will adopt the sign of the middle term. Are you with me? Okay, so the highest factor between 3 and 1 is 3, so it will adopt the 3 will adopt the sign of the middle term. Okay, because 3, look at it, 3 minus 1 is 2. That works. Positive 3 times negative 1 gives you negative 3. So these factors are 100% correct. Then, after factorizing, zero factor law, as you know, then the roots. Now look at these roots. If you were to tell me what is their nature, these are the actual solutions, guys. These values are not values that are under a square root, okay? These are the actual roots. So negative 3 and 1, are they real numbers? Let's start there. Is negative 3 and 1 real numbers? Are they real? Because I'm going to say the roots are real if you can tell me that minus 3 and 1 are real numbers. Are they real numbers? Negative 3 and 1, are they both real numbers? Yes, Gift says. Okay. Negative 3. Look at this. Look at the misconception. Look at what Trench is saying. He says negative 3 is non-real and 1 is real. Yeah, now this is what I wanted people to make a mistake about. And why? Because I was eager for someone to actually say this comment. So, Trench, you've said the comment I wanted to hear so that I could teach something from your comment. Okay. Remember, guys, okay, when we were discussing or determining the nature of roots using the discriminant, this b squared minus 4ac, what did I say to you guys? It belongs where? Underneath a square root. Okay. Please, guys, it belongs underneath the square root. So the value you are getting for delta, which is this one, if it's negative, remember it's under a square root. Hence, we say that delta is less than 0 for 1 because it's a negative value. But when we speak about the roots, we say the roots are non-real, guys. Okay, non-real. Because this negative 3 is under a square root, this one. Okay, yeah. Negative 3 as a number in and of itself is not a non-real number. But because this delta represents a value that is underneath a square root, that suggests that its roots are non-real. Okay, it suggests that its roots are non-real. I repeat, this negative 3 in and of itself, the number negative 3 alone, not being under a square root, this number is a real number. But because it represents a value of b squared minus 4ac, which is under a square root, which is a value that's less than 0, it would suggest that the roots are non-real. Okay, very important, this point that I'm making. Okay, yeah. So that's the meaning of when delta is a negative value. We say its roots are non-real. But now, in this situation here, we are determining the nature of roots by solving the equation. So we've solved the equation. We found what the roots are. One of the roots of x is negative 3. The other root is positive 1. My question to you, these are the roots. What is their nature? This minus 3 and 1. Is minus 3 and 1 real? Or is minus 3 and 1 non-real? It can't be different things. This negative 3, is it a real number? And is this positive 1 a real number? That's my question to you. So I am hoping my friend there, Utrench, Okay, Oreleobohile said they are both real. And I hope you guys understand that negative 3 and 1 are both real numbers. So we say that the roots, negative 3 and 1, are what? Are real. Okay. Then 2, rational or irrational. Okay. These numbers, guys, these are the solutions. These are the roots. We've just found the roots. These are the roots, these two. Remember, the solutions of x are the roots here. They are the roots. Negative 3 is one of the roots of this equation, and 1 is one of the other roots of the equation. These are the actual values, the actual solutions of this equation. Okay. And Tlotlo is asking, how are they real, manje? Okay. My question is, what are real numbers? Let's start there. What are real numbers? Do you guys know what are real numbers? Okay. So for instance, is 3 a real number? Just the number 3. Is it a real number? Do you guys know the numbers that are in the real number system? Is 3 a real number? Is negative 1 a real number? Just on its own, guys. Okay. Sbani says all numbers from negative infinity to positive infinity are real numbers. Do you guys understand that? Can you internalize that? All numbers from negative infinity to positive infinity are what we refer to as real numbers. They are all the numbers on the number line. Thank you so much, TXT. All those numbers on the number line are real numbers. So let's start there. Okay, real numbers are all the numbers on the number line. Okay, all right, all of them, all of the numbers. Okay, so if I am solving an equation, I get 2 of the roots of the actual equation because I have solved the equation. I get the roots. One of the roots is -3, the other one is +1. My question is -3 and 1 real? Are they real, guys? Is negative 3 and 1 real? That's my question. The roots it themselves. These are the actual roots of the equation. Are they both real? Okay. And the answer is yes. Negative 3 and 1 are real numbers. 2. Negative 3 and 1, are they rational numbers? What is a rational number, guys? Is negative 3 and 1 rational? Do you remember in grade 10 when you guys defined what a rational number is? You said a rational number is a number that can be written as a fraction, where the numerator and the denominator are integers, and where the denominator cannot be 0. Okay? So negative 3 is a rational number. 1 is a rational number. So both of these roots are actually rational. And then last but not least, are these roots equal or unequal? Okay? Are these roots equal? Is negative 3 equal to 1? Or is negative 3 not equal to 1? Okay, so these roots are unequal. So if you were to be required to find or determine the nature of roots by solving the equation, I mean, this is what you would typically do. You would solve the equation, get the actual roots, and then comment on what you see in those roots. Okay, that's what you would do if they were giving you a question to say determine the nature of roots with solving the equation. Yeah, women of faith, like I said, you asked me to help you or ask the question where you are asked to determine with solving the equation the nature of roots. Okay, remember, typically we use the discriminant to determine the nature of roots. Okay, but since you asked me to determine the nature of roots by solving the equation, I was just explaining how you would go about it. So you get the actual roots. This is a negative 3 and 1. They are not under a square root. So negative 3 and 1, just as the solutions, as the roots themselves, they are real numbers, both of them. They are rational, both of them. And they are unequal because they are not the same numbers, you see. Yeah. So you just look at the roots and you comment on what you see because these are the roots. All right. In the previous question, remember, this x squared plus 2x minus 3. Remember, we actually determine the nature of roots of the same, okay, equation, but we used the discriminant to determine the nature. Okay, we identify A, B, and C after knowing that this is in standard form. We use the discriminant, we substituted, we got delta. Now remember, delta is the discriminant, but this 16 represents a number that is situated where? Underneath the square root. So this is like the square root 16. It belongs here, you know, in the place of delta. Which same formula, which is this expression is situated in the quadratic formula. All right. Okay. So this helps us to determine the nature of roots. Now, what did we find? We got 16. Okay. Yes, gift. If you tie this into functions, then you are talking about the x-intercepts. Well, now you see that connection. You being able to make that connection will help you, because when you guys do functions, you are going to have to integrate nature of roots, guys. You are going to have to integrate nature of roots with functions. You know? And then when you integrate nature of roots with functions, then other things become clear for you. All right. So this is the discriminant. Delta is equal to 16. This is the discriminant, a value that is able to help us to know what the nature of roots with. We don't have to solve for the equation in order to get the nature of roots. We can just use the discriminant. We get the value of delta, which is 16. This value of delta is greater than 0. It's also a perfect square because 16 is a perfect square. And then we can go ahead and speak or discuss the nature of roots. Okay. Trent, you're asking about simultaneous equations. You can go to my YouTube page. We've done simultaneous equations, my friend. You can go there. They're there. Okay. So delta is greater than 0 simply means that the roots are real, because delta is greater than 0. Okay. 2. Delta is a perfect square simply suggests that the roots are rational. And then delta is greater than 0 also means that the roots are unequal, right? So I was able to discuss the nature of roots without actually solving them, okay? But you can see whether you solve the equation or whether you actually deduce the discriminant, you are still able to discuss the nature of roots. But the thing is, in your the actual syllabus, when they ask you to determine the nature of roots, they are asking you to actually utilize the discriminant. Hence, we are, emphasizing the discriminant, as the way through which we can be able to discuss or determine the nature of roots. Okay, so and that is that, guys. If it's not equal to 0, remember, guys, this is delta greater than 0. That means delta is not equal to 0. But because it is a perfect square, that's why the roots are rational. Okay? If this value of delta is a perfect square, it will always mean that the roots are rational. But if the value here, okay, delta, for instance, is 29, 29 is not a perfect square. So that means if it's not a perfect square, delta is not a perfect square, then the roots are irrational. You see? Yeah. Okay, but it must be positive and it must not be a perfect square in order for the roots to be irrational. Okay. I don't have to do a equation but I'll do it anyways for your enjoyment. So let's say x squared plus 3x. Actually, sorry, let's say x squared okay, let's look at this one. Yes, Bokamos, I'm done completing the square. Done all of those things, guys. Grade 11, if you go to my YouTube channel and you go to the grade 11 playlist, they are there, grade 11 playlist. I did it under the grade 11 topics that I did in the holidays. So those are all there. Like all the topics from the beginning, the ones that are done in grade 11 at the beginning of the term 1, at least up until just before nature of roots, I've done them. They are uploaded. They are there in the YouTube channel. You can check them out. Simultaneous equations, surd equations, fraction equation, algebraic fraction equations, simultaneous equations, all these inequalities, yeah, they are there. Go check them out. Okay, YouTube channel on the link, my bio, my friend. X squared plus 16x plus 64. Let's check this one out. Okay, we use delta when we are asked to discuss or determine the nature of the roots. Okay, that's when we use delta. Okay, so those who are not caught up, hopefully when I upload this video, you'll be able to check the lesson from the beginning and then see what you need to see. But I'm gonna go up until this far. There are 2 other types of questions that are usually asked under nature of roots, but I'm not gonna do them today. I'm gonna do the first part, which is this today, and then maybe tomorrow morning I'll do the second part, okay, just before I head to my session that I have physically with some students. Discuss the nature of roots x squared plus 16x plus 64. Okay, Musa Changa say we'll do trigonometry and so forth after we are done with the algebra, because after this, when I'm done with the algebra, nature of roots, word problems, then we'll be able to do other things. Okay, you just need to be patient. You guys need to be very patient with me, you know. But obviously there are other resources to learn certain things, you see, so don't feel limited by me. Don't feel held back by me. So discuss the nature of roots. X squared plus 16x plus 64 is equal to 0. So let's check this out. I'm thinking morning study, I'll do a 7 a.m. with you guys, 7 a.m. Yeah, because I need to leave shortly thereafter. So I'll do a 7 a.m. tomorrow morning, 7 a.m. We'll do a morning 7 a.m. with the grade 11s. So discuss the nature of roots x squared plus 16x plus 64. Okay, I don't know what's happening, but something is happening on my screen. I just hope it's not what I think it is, because if it is what I think it is, then they're gonna basically, it will be an hour, KP. It will be an hour, 7 to 8. Discuss the nature of roots. X squared plus 16x plus 64 is equal to 0. So first things first, we'll be at school at 7. Oh, okay. Maybe we can do later on then. Or 6 a.m. Precious, you guys. You guys are hilarious, my goodness. Or 6 a.m. We'll see. We'll see, guys. We'll see. No, that's fine. We can do evening, and then you guys are saying we can do evening. You want to do evening? You think that would be more appropriate? Evening. Okay, we'll do evening then. We'll do evening, guys. We'll do evening. You guys are hilarious, my goodness. Okay, evening. No, 6 a.m. I won't be able to do 6 a.m. guys, trust me. It's a pipe dream. I'm not a man. Not during this time. So we'll do evening. Okay. We'll do evening. Same time, same place, 9 p.m. We'll do the evening. Let me just do this one. X squared plus 16x plus 64. It says discuss the nature of roots. Okay. So first things first, we must ensure that the equation is in standard form, which it is. Then we identify A, which is 1, B, which is 16, C, which is 64. Okay. Yeah. Hope we can see that. Then we write delta is equal to b squared minus 4ac. All right. Those are at 7, grade 9. Delta is equal to b squared minus 4ac. Then we substitute. Precious fighting here. Okay, 16 squared minus 4 times 1 times 64. All right, can you see that, guys? So obviously there, yes, those are at 7 a.m. for grade 9. 16 squared minus 4 times 1 times 64. I'm sure you guys can punch this into your beautiful calculators for me, and I'm sure you'll see that it gives you the glorious number that you guys have all been waiting for, that you've been wanting delta to be, because you've been desperate that that number appears, right? Minus, we got 4, we got brackets, we've got 1, we got 64, 0. 0. Delta is equal to 0. Right? Yes, it is, woman of faith. It's the last example. Okay. And then we'll continue on with the other ones tomorrow. Yeah, and maybe look at some exam type as well. So delta is equal to 0. So what does that mean? If delta is equal to 0, guys, delta is equal to 0, right? Plus, we know that delta is a perfect square. Hopefully you guys know that 0 is a perfect square. Hopefully you guys know that as well, eh? Yeah, because it is 0 times 0 that gives us 0, right? So 0 is a perfect square as well. So what we then conclude is the roots, if you didn't know, the roots are obviously real, because 0, okay, would infer that the roots are real. 2, the roots are rational, because 0, give perfect square. Lastly, the roots are equal, right? Because the roots are equal. So these are the 3 things we write based on the nature of roots. Now I just want to show you guys something. Yes. Okay, there it is. Hopefully those who want to screenshot can screenshot. This is the question, discuss the nature of roots. So make sure that the equation is standard form. We identify A, B, and C. We write down the discriminant. We substitute. We write down the value of delta. Then we conclude about the value of delta, a few things. And then last but not least, we say the roots are real, they are rational, and they are equal. Rational as in like 0 over 1. Amen, woman of faith. What more do you want? Okay, yeah. But this is also because 0 is a perfect square, you see. So that would then infer that the roots are rational. Because when delta is a perfect square, the roots are rational. It goes without saying. It goes without saying. Okay. And then when delta is equal to 0, it also means that the roots are real. So there are 2 situations where the roots are real. The roots are real when delta is equal to 0, but also the roots are real when delta is greater than 0. 2 situations, okay? When delta is greater than 0, the roots are real, and when delta is equal to 0, the roots are also real. But when delta is less than 0, the roots are non-real. Full stop. Are we together, guys? I hope we are together. I hope we are feeling this and we are feeling it well. I just wanted to show you something very quickly. So graphically speaking, okay, graphically speaking, if you are looking at something like this where delta is less than 0, meaning the roots are non-real, Gift said something earlier on and said that, so does that mean that, you know, if we are saying non-real, it means there are no roots. Okay, so graphically speaking, that's like drawing a function where you can see that the graph does not cut the x-axis. Because there are no roots, that means there are no x-intercepts. And I mean, I can clearly draw this graph as one that is concave up where there are no x-intercepts, simply because you can see my coefficient of a is a positive value. Okay, so this would be a good graphical representation of a function where we can see that there are no roots because the roots are not there. Look at this one. Okay, same thing here as well. Okay, yeah, roots are non-real. It means that there are no x-intercepts. Look at this one. Delta is equal to 16. Okay, remember we said that the roots are real, rational, unequal. So obviously if they are unequal, Okay, depending on what we can see. I mean, of course, here you can see that the roots here, the x-intercepts, one would be -3, the other one would be +1. So that means that would be like a function that's sort of like this, okay, where there are 2 x-intercepts, okay, yeah. Okay, so basically graphs here come into play in the sense that they might sometimes ask you to look at a graph and then discuss the nature of roots. So for instance, this would be a typical example where one x-intercept is negative, the other one is positive. So that means there are actually real roots here, and they are unequal. They are also real, and they are rational, you know, if they had specifically written down -3 and 1, if that makes any sense. Okay, and then obviously with this one, where delta is equal to 0, this is a typical example where a function, okay, is just simply touching the x-intercept once. There's one root and it touches the x-intercept once. That's why we say that the roots are real, they are rational, but they are also equal. In other words, there's one value, okay, x is equal to 8 or x is equal to 8, if that makes any sense. Okay, so basically situations like this would say that the roots are real. There's one x-intercept, okay, whereas here the roots are unequal. There are 2 x-intercepts, okay, and so forth. So guys, let's call it a night here. Okay, I hope you guys I hope you guys learned something from this. You know, yeah, the discriminant or delta determines the nature of the roots without solving the equation. Where do we get this b squared minus 4ac? Here, guys, underneath the square root, okay, which is very, very crucial and very critical. Game challenge, I'll send it in the group, guys. I'll send it in the group. I actually, funny enough, did not have anything available for game challenge, so I'll send it in the group, okay, and I'll also post it for my sweet, amazing, wonderful people that joined in for the first time. I'll post it on the TikTok page as well, so that you can have it, okay, or you guys can go to my link on the WhatsApp channel and then you can basically get it there as well. Okay, I will upload this on the YouTube definitely. I will do that, Women of Faith, as soon as I can. I'll log out and I'll definitely upload it as soon as I can. Something is happening on my screen and I don't know what it is. Like, it usually happens when they are about to pull out a restrictive measure on me, and I don't know, it's something circling around and around and around and around. They usually do that. I don't know why. How do we know if we're solving without? I don't know. Presh, you need to rephrase your question, or you can voice note me or something like that, but I don't know if I'm understanding your question. Spani, really? Wow, what an amazing one that I am then, if that's the case. I mean, imagine, bro, I am here like teaching maths and I don't understand how that works. Oh, working with numbers. Are you kidding me? No, man. These people need to chill, man. So it's like a maths teacher trying to help out some kids in South Africa, for crying out loud. They need to calm down, for crying out loud, before I go cray-cray on them. I don't know, go cray-cray on this platform. Yes, Women of Faith, you can. Yeah. Tell her, Musa Changas. Pressure has really been making me feel so good, by the way. You know, like, I don't know if I'm not trying to coerce you guys now to like sending me messages and stuff like that, but you know, when something really comes genuinely from someone's heart and they just like so appreciative, like Precious probably sent me like 2 solid voice notes that have like been a reflection of her appreciation of what we've been doing, especially during the holiday period, like, because she is seeing like a direct impact it's having on her studies, like literally at school with the mathematics. And it seems like things are going very well. She's writing tests and she's like getting 100% and stuff, and like she's like this genius Gigi girl, you know. So yeah, she sent me some, like 2 solid voice notes that I've just been like, yo, that's amazing, and I'm very proud of her. Like, I'm proud of all of you guys. I know some of you may just not be, maybe you're not those kind of people that really like will probably voice out or say things or whatever the case may be. I know some of you appreciate in the heart, some of you appreciate in silence and so forth. But I must say, I'm when it comes to those, they talk about love languages, and I think my love language, I love when people are able to actually say things and show appreciation. I think words of affirmation, that's my love language. That's how I feel like I'm receiving love and appreciation, if you will, when people are able to articulate it in words. So yeah, so thank you. I really appreciate that, and I'm happy that, I mean, that's the whole intention and motive. I'm hoping that you guys can really just get the best. Okay, no Musachanga say, not even this is like from a genuine place, man, yeah, I'm not doing this for that. I'm doing it so that you guys at the end of the day, it will make me absolutely happy to see you succeed. For instance, like there's a young lady that is currently studying medicine at the University of Stellenbosch. And this young lady, I had the privilege to meet in a particular program, taught her like grade 10, also 11, and then grade 12. Did not have the privilege, but like it was so amazing to see that young lady get 100% for grade 12 end of year last year. Like, she got 100% for maths. Like clean 100. And I was just like, yo, I was so excited and elated for her. Now she's studying medicine at University of Stellenbosch, and like she's killing it, man, and she will kill it. And like she was just so appreciative as well. Like apparently I had said something to her at some point, I think it was back in grade 10, and I had said to her that, and I did not mean this badly when I was saying it back then, guys, like don't get me wrong, I'm not sexist as well, but I did say to her, and this was like more of coming from a place of concern. I was starting to see many young ladies really lose their mojo when it comes to mathematics. They come into grade 10, they are hot and pumping, the maths is good. But then like 11, 12, they somehow lose it. I don't know if it's because of distractions. I don't know if it's because of guys. I don't know if it's because of their hearts. But many of them, they just lose it somewhere along the line. And then by the time they get to grade 12, I had been noticing that some of them, they are not as good anymore, or there's not that much dedication, or not that much of a hunger anymore to actually really excel and do very well. So I had expressed that concern to her back then in grade 10, and I had said, ladies have a tendency, like my female students have a tendency of just copping out or not really enduring till the very end. So funny thing is, in a address that she had given to the learners, on the day when they were actually like having their last assembly with us, and she was actually motivating them and sharing how she had gotten 100% and some of the habits that she had sort of like inculcated in her own life to ensure that she's able to sustain such a performance and get it at the end. She then mentioned that, this teacher had told me this some years back, and I was wanting to prove him wrong. And I was so happy, I was so elated when I heard that, because I was like, so it really stuck with her back then, and she wanted to prove me wrong. And I was happy that she was able to prove me wrong, because ultimately I do believe that, a lot of, people do have potential. And sometimes I do tend to say things, not in any way meaning it negatively, but it's more of like trying to make you realize that, you can make the decision now to not become part of that narrative of people that have fallen into the same trap, where they have not been able to perform and attain to a certain level of performance simply because they were distracted by other things. So it's so important to just get your game on, get your focus on, and really utilize this time and this period of your life, of your academic life, to just make sure that you don't lose out on anything. If there's a bursary lined up for you by the time you finish grade 12, and it will come based on your excellent academic performance. You cannot lose out on that opportunity. Any relief that you can offer to your parents of not paying for your varsity education, and if you can attain that by yourself, simply because you are able to attain unto a certain academic performance and get a bursary and be able to educate yourself, that will be a win in and of itself. You'll be affording your parents relief, and you'll be affording them a sense of like a comfort as well, because they will know that you are sorted and taken care of. Okay, so yeah, guys, any sacrifice, any worthy sacrifice that you make for your educational pursuits and future dreams is worth it, man. It's validated. So you just keep on pushing, man. Yeah. So whatever little thing you're doing in your corner, towards your education, and it's an educational investment for your future. You go, girl, you go, sir. You keep it up, and don't let down. Yeah, every little effort is worth it. It's validated. So yeah, guys, otherwise, thank you so much. Thank you for joining the live. It was cool. I loved it. Hopefully you guys can just grow from strength to strength. And grade 11 maths. Hi guys, you can do damage this year, if you know what I mean. You can do something you've never done before as far as your maths performance. So let's do this, man. Let's do this. Let's set records. Let's kill it, like, completely. I believe in you. I totally do. So yeah, with those words, guys, let me love and live you. Thank you. Yeah, it was good while it lasted, and I'll definitely then be seeing you tomorrow. Okay, thank you, guys. Let me see you. Ciao. Cheerio. Cheers. You're welcome. You are welcome. Welcome to my world, I have made one your thing. Can't escape this life. What's happening? You see, something is happening with this life. It's kill.